Okay, this problem actually was presented, or this question was actually presented with three problems. I'm only going to answer problem number one, which is to evaluate the limit of this function right here as x approaches 1. Here is that function defined on Desmos. And if we take f of 1, we're not surprised to see that it's undefined because we're dividing by 0. But if I take f of 1 point something very close to 1, but not equal to 1, I get this number right here, which happens to be, looks like very close to radical 3 over 3. And in fact, that is the limit right there. Question is, how did I get there? So here is the limit we're trying to evaluate. If we try direct substitution right now, this little rectangle down here shows you what happens. We get 0 over 0, indeterminate form, which means we can apply L'Hopital's rule, which means that the limit as x approaches 1 of the derivative of the numerator over the derivative of the denominator will have the same limit. So the derivative of inverse sine is 1 over the square root of 1 minus whatever the parameter to inverse sine is, squared. So if I square x over 2, I get x squared over 4. But then I have to multiply by the derivative of the inside, which is this 1/2. In the denominator, the derivative of x minus 1 is just 1. So I could do direct substitution right now, but I simplified this expression a little bit before direct substitution. I can see that I can maybe get a common denominator here, 4 over 4, and write 4 minus x squared over 4 under the radical. And this 2 is being multiplied times that radical. And if I take the square root of 4, I get 2. So these 2's cancel out. So it's really 1 over the square root of 4 minus x squared. And as x approaches 1, that's 1 over the square root of 3, which if I rationalize it, there you go, radical 3 over 3. So this original function, as x gets close to 1 but not equal to 1, that's the limit. There you go. Hope that helped. If you have any questions, post a comment. If you still are stuck on the other two, post a comment and I'll update the video. There you go. Hope that helped.